PV equal nRT.
Keep this in your mind and nRT. What's the name of this law?
The ideal gas law.
You must memorize the name, ideal gas law or equation. Ideal gas law or equation. You must know it and know it very, very well. Next, we have also, before the ideal gas law, there were some very important laws, or before that. There are four physical matters, physical properties of gas which are important. What are these four? It's actually P, V, and N, and T. Okay, what's P?
Pressure.
Pressure. What's the unit that we use for it?
Atmosphere.
Atmosphere. There is another unit which is called Pascal. We can change Pascal to atmosphere, but in this equation we're going always to deal with atmosphere. Okay, I want you to know and know very well that atmosphere is equal to how many millimeter Hg?
760.
You must memorize this number, 760 millimeter Hg. So the height of the column, millimeter Hg, millimeter, 760 millimeter Hg. What's the other name for it? Instead of millimeter Hg, what's the other name? Torr. Very good. Okay, the other constant is V. What's V?
Volume.
What's the unit that we use for it?
Liter.
V. Good. What is T?
Temperature.
What's the unit you use for it?
Kelvin.
Kelvin.
Good. And N?
Number of moles.
No, moles.
Mole. And the unit that we use is mole, and I hope everybody knows the mole. Okay, now, there were three important laws before the ideal gas law. What are the three important names? Give me the names of the scientist and the law. First one is called?
Boyle.
Boyle's law. Boyle's law. Okay, what's the law?
P1 V1 equal P2 V2.
P1 V1 equal to P2 V2. What is the condition?
T and N constant.
N and T must be constant. If you change N or change temperature, then this law will not apply. Okay, good. What's the second one?
Charles law.
Charles. Or what's the other name?
Gay-Lussac.
Gay-Lussac.
Gay-Lussac law. Both of them are the same, even though some people differentiate between them. What's Charles' law?
V1 over V2.
Or what?
V2 equals
Over T1.
Or actually, I would prefer V1 over T1 equal to what?
V2 over T2.
T2. Very good. Of course, you can play with this one and make it V1 over V2 equal to T1 over T2 is the same thing. But this is the way I wanted to write it. What is the condition?
and N.
P and T.
And N.
G. Oh.
Don't change the amount or the pressure. The other way to write also Charles' law, which sometimes is called Gay-Lussac, is actually to write P1 over T1 equal to P2 over T2. What will be, this is sometimes called Gay-Lussac only, but I think both of them are called both Charles and Gay-Lussac, no problem. Okay, what's the condition in this case, in the second one?
N and V is constant.
N and what?
V.
V must be constant.
V.
Excellent. Okay, what's the last? So this is law number 1. Both of these is now law number 2. I want the third law. What is it?
Avogadro's law.
Avogadro's. What's the law?
V1
N1
over
over
N1 equals V2 over N2.
What's the condition?
P on T is constant.
I hope this is clear. Good. And we reach to the ideal gas law. Ideal gas law. Okay. I also told you that I gave you this information and I will repeat it one more time. What's the meaning of STP?
standard temperature and pressure.
What's the standard temperature and pressure?
0 Celsius and 1 atm.
0 degree Celsius and 1 atmosphere. The pressure. 1 atmosphere is the pressure. I told you that 1 mole of gas at STP has a volume
22.4.
22.4 liters.
Yes, I want you to memorize this. Has a volume of what?
22.4 liters.
I want you to memorize this number. 1 mole of gas at STP has a volume of 22.41. Okay, now what's STP one more time? Standard temperature and pressure, which means what's the temperature?
0 Celsius.
What's the pressure?
1 atm.
Good. Let's apply the ideal gas. What's this law? The ideal gas law. From the ideal gas law, what's R?
Constant.
Yeah, but what is the equal to from the equation?
PV over NT.
Over
NT.
yes, NT. I have to do it this way. Yes, well. Let's apply this rule to this R. What's the pressure for this gas? For gas, I'll call it gas A. What's the pressure of gas A?
1
1. What's the volume?
22.41.
Okay. And what's the N?
1
1. What's the temperature?
273.
200.50.
0.15015. Okay, then calculate R.
Zero point 0.0820.
0.0821. Exactly. Okay. As I said, don't memorize this number because it's available for you in the periodic table. But this number is not available. You must memorize it. And you should be able to derive R from this simple equation. Is this easy?
Yes.
Yes.
Next. There are different values of R, like this one and the others. This one, the one we just calculated. And that's why, look at the unit. It's liter atmosphere divided by Kelvin mole. The rest are not important. This is not important, not important, not important. This one is very important, and we will use it at the end of the chapter, and this one is not important. And this one, the third one, so I'll call this one number 1 and number 2 are important. Number 1, we already dealt with it. Now, number 2, why is it important? It is the same R. What's the difference between this one and number 2? What's the unit?
Joule over Kelvin times mole.
What's the unit for joule? What do we use joule for?
For energy.
Energy. So we're going to use this R, not this R, when we deal with energy. Clear? But these are all equal. That's why I will say that 0.08268206 liter atmosphere divided by Kelvin mole is equal to what? 8.314 joule divided by Kelvin mole. Can you see this?
Yes.
It is easy, right? Good.
Yes.
I want you from this to tell me, or now, what can we conclude? We can get rid of K and mole, K and mole. What will be left for us? 0.08206 liter mole equal to 8.314 joule. If we have 1 joule, then how many liter mole is this?
We divide this by 8.314.
Go ahead, give me an answer.
It's I'm sorry, for just a moment. It's 0.00987.
9.87 times 10 to the power minus 3 or minus 2?
Minus 3.
Okay, maybe, I don't know what's the number, but I want you to be able to relate joule to liter atmosphere. You have to be, if you need it, it's there. Good. Next.
So, Doctor, we need to memorize these numbers, right?
No, don't memorize any number. These two numbers are available in your periodic table. Look at your periodic table. Do you have your periodic table with you?
Yes, okay. Got it.
Get from your pen, conclude this number. Don't know it. If you need it, then change it by this method. Okay.
Same thing.
Good. All right. With this, I will stop here with chapter 10. And then, okay. And then what else to do? I will move to
Doctor, is the last relation between joule and liter atmosphere important?
no, but maybe you will use it when you change from liter atmosphere to joule at the end of the chapter, not now.
Okay.
Okay, good. Next, I already
We can't hear you.
right? Not hearing me. Why?
قطع
Your
لك
voice
طبعا.
is lagging.
Hello.
We can hear you now.
Okay, good. All right. The homework for chapter 2 is going to be, I want it on next Sunday. So do it either today or whatever, and give it to me before the end of Sunday. Okay. And We will go over the homework just to just for revision actually. Okay, good. Next, which of the compound is strong electrolyte? In order to have strong electrolyte, what should we have?
Strong acid or ionic compound?
Yes, ionic compound. Ionic compound is, which one is the strong electrolyte? Is water strong electrolyte?
No.
No.
Fine.
No.
It's not electrolyte.
How about
It's
oxygen?
No.
No.
No. How about glucose?
No.
No.
No. How about H2SO4?
Yes.
Yes.
Yes. Yes.
It's one of the certain strong bases.
The strong acids.
Acids. Yes.
One of the strong acids, and yes, it is the strong electrolyte. How about acetic acid?
It is weak electrolyte.
Weak. Why? Because it is also weak
Acid.
acid, so it is weak electrolyte. And I want to stress one more time, we know the strong acids. Everybody knows the strong acids, right?
Yes.
Is it 7?
Yes.
I remember it's 7 acids, right?
Yes.
Yes, they are 7.
7 or 8, I forgot one, but I know them. But anyway, anything it's not among these 7, then it will be weak electrolyte. And organic acid, what type of organic acid we have?
Carboxylic acid.
Anything, carboxylic acid, anything like acetic acid, anything contain which group?
COOH.
Or we can write it this way, or we can write it like this one is acetic acid, or like what's written here, CH3 COOH. هذا الخل هذا الخل هذا الخل. That's the way we write it. Okay, and these are all weak acids, and as a result they will be weak electrolyte. What are the weak bases, weak organic bases?
The molecular base.
Contains in nitrogen.
In, like for example, CH3 NH2 or CH3 N CH3 CH3H or CH3 3N. All of these are weak bases. Why?
It
They
contains
contain nitrogen.
N. So these are all weak. What? Weak what?
Bases.
Bases.
Or also weak electrolyte. Clear?
Yes.
How about CH3OH?
strong electrolyte.
It is
Strong-
alcohol.
strong.
Neutral.
This is non-electrolyte.
Not acid or base or ionic compound.
Yes, because OH group in organic compound, OH group does not dissociate, so it is non-electrolyte. Anything. How about this compound? CH3, CH2, CH2, H2OH. Long compound. How about this compound?
Non-electrolyte.
Non-electrolyte, because OH is non-electrolyte. Good. Okay, next. Which of the chemical equation describe precipitation reaction? What's a precipitation reaction?
One of the
There is a
products
solid
will
in the
participate.
One of the product will become solid. How is it going to be solid? If two ions are what?
Insoluble.
If two ions among, you remember the table 4.1 and 4.2?
Yeah.
Yes.
You have to memorize which ion will precipitate with which ion. Look here, let's talk about SO4 because it's talking about SO4 2-. SO4 2 minus will not make precipitate except with which elements? Which ions?
Ag.
Ag plus.
G plus. What else?
Hg2 plus 2.
Hg2 2 plus.
What else?
PP.
Pb 2 plus.
What else?
Calcium 2
CH.
plus.
Calcium 2 plus, which is alkaline.
Barium.
And then strontium,
SR.
one below it, and then barium.
Barium.
Exactly. So if you know this fact, which one and two, which one is the correct answer?
B.
Yes, B.
B is the correct answer because calcium will precipitate with SO4. And calcium will precipitate with SO4. That's why this is the correct answer.
Doctor,
Yes.
in this type of reactions, we need two reactants, right?
Yeah.
For example, number C is absolutely wrong.
Oh, yes, I agree. Of course.
Okay.
C is wrong because nothing is reacting with anything. It's just decomposing. But it's not a precipitation reaction. Precipitation reaction is to have two ions, X plus Y minus, to make XY. That's called precipitation reaction. There must be two ions interact to make this thing, like this thing. Ba 2 plus will interact with SO4 2 minus to make Ba SO4 solid. This is called precipitation reaction. Clear?
Doctor,
Yes.
and the second choice, which is the correct choice, the product HBr, why it's not aqueous?
Just a second. Again, what's the question?
And the product HBr, why it's not aqueous, doctor?
Which
And the second choice, the correct choice.
the correct choice. Yeah, it is gas. It became gas. I mean, it came out of solution as gas. It's okay. If you dissolve it, it will be aqueous, yes. But at this time, it went as a gas.
So it's not soluble?
It is soluble, but it can come as a gas. Yani, if you put HBr in water, it will be H plus Br minus. But if you take the water away, it will come out as HBr, gas. So if you dissolve it, it will become ions. If you take the water away, it will become gas.
Okay.
That's it. But it's the same thing. Yeah. Good. Question number 3. What's the meaning of displacement reaction?
Replace.
Yeah.
Yes. What's replace what?
One metal will take place another.
And what happened when it takes place? What will happen to the oxidation and reduction?
Oxidation.
One will be
One of them
oxidized,
oxidized and one will reduced.
one will be oxidized and one will be reduced. Right? Okay. Which one among these is displacement? Is it A, B, C, or D, or E?
B.
B.
B, correct. Why? Because if
Because
E,
Al displaced Fe.
if E, what's the charge? The Fe replaced the aluminum. What's the charge in Fe here?
+3.
What's the charge in Fe here?
0.
0. What's the charge of aluminum here?
0.
What's the charge of aluminum here?
3 plus.
So this is displacement reaction. This is displacement reaction. All right? I hope so. Good. Based on solubility rule, which of these processes will occur if solution of CaSO4, by the way, this is question 2 and question 4 are exactly the same. Don't forget, we're going to use SO4 as one of the ion, And don't forget the ions that precipitate with it. Now, read question 4. Based on solubility rule, which of these process will occur if solution of CuSO4 and BaCl2 aqueous are mixed? What will happen?
C.
C.
Yes, C.
Is it C or D or
C.
or E?
C.
C, C.
C
C.
is the answer. Correct. What will happen? Ba will take SO4 and will come up out precipitate, and then Cu. And let's write for this one. Let's write the full reaction. Cu SO4 will react with BaCl2 to make SO4 plus CuCl2. Okay, can you make this now in ionic form?
Yes, Cu2 plus.
Plus SO4 2 minus to give you, and plus Ba 2 plus plus 2Cl minus to give you what? Ba
Solid.
Oh, sorry. Yes, Ba is
Doctor, it is solid.
yeah. Okay, this what will happen now. Ba is 4 solid plus Cu2 plus 2Cl minus. Okay, next, what's the net ionic equation?
SO4 2 minus.
SO4 2 minus plus Ba 2 plus to give you BaSO4 solid. What do we call the Cu and the chlorine?
Spectator ion.
Spectator ions.
So this is what will happen. BaSO4 will precipitate, and Cu and Cl minus are spectator ion. I hope so. Good. 5. Identify the net ionic equation for the following reaction. Net ionic equation. Again, let's write the equation. NaCl aqueous 2 NaCl plus Hg2 NO3 twice give you what? 2 NaNO3 plus Hg2Cl2. Okay, can you make it ionic? Yes.
2Cl, 1
2Cl
negative.
Plus
Hg2 2 plus.
Hg2 2 plus what?
2
2NO3
3
Minus. Good. What are you going to get?
2Na
2
plus
Na
Na plus
2NO3 minus
2 minus plus
precipitate.
Hg2Cl2 solid. What will be the net precipitation reaction?
We get rid of the spectator ions.
Exactly. So Hg2 to plus 2NO3 minus to give you Hg2Cl2 solid. Okay.
Doctor, do you mean 2Cl instead of 2NO?
Ah, so of course. What the Cl? Oh, of course. Thanks. Okay. Let's see. Of course. 2Cl-. Okay, yes. So this is the Neutralize equation. What do we call these ions?
Spectator ions.
Spectator ions.
Good. So what's the answer for 5?
B.
B, exactly. So this is the correct answer. Now, is this one is how about C? C is the same. Is this correct?
But it's
No, it's not correct. Why?
No, Hg is different.
G is
It is
Hg.
mercury too.
It's not Hg plus. It's Hg2 2 plus. Is this clear?
No.
Okay, good. Question 6. Complete the following reaction and identify the bronze acid. So complete the reaction. What are you going to get?
NaCl plus H2O.
NaCl plus H2O. Good. Now, that is what we're going to get. Now, what's the, okay, before I answer this question, we have 2 definitions for acid and bases. The first one is, name is what?
Arrhenius.
Arrhenius, Bronsted,
And Bronsted.
Bronsted.
Okay, what's Arrhenius theory?
Any compound that gives H plus is acid. And any compound that gives OH minus is base.
Give H plus is acid. And base,
OH minus.
give OH minus. Okay, how about Bronsted? How did he define it?
It gives one
Acid is
proton,
proton donor.
right?
Give H plus, same like Arrhenius, the acid. How about the base?
Take,
Accept H plus.
Give or take what?
H plus.
Okay, now in this reaction we completed an NaCl plus H2O. Which one, according to Bronsted, which one is the base?
NaOH.
NaOH is the base. Why?
Because it take H plus.
It took the H plus to make the water. It takes the H plus to make the water. Is this clear? So which one is the answer? Yes.
Doctor, the displacement reaction only comes for metals, so it doesn't come here.
Displacement, of course, between metals displacement.
Oh, okay. I got confused because I thought that this was a displacement reaction.
No, this is the acid-base reaction. You have to know the definition. This one is called acid-base reaction. Displacement is between metal and metal. Precipitation between 2 ions that will precipitate. All of this is the name of the reaction. Good. So what's the answer for 6?
E.
E. Yes, exactly. So the answer is E. Good. Now, when we have oxidation and reaction, before we go further, let me ask you, what's the oxidation state of iron in here?
Two plus.
+2, exactly. Okay, how about manganese?
7 plus 7.
+7, very good. Excellent. How about this iron?
Plus 3.
+3. How about this manganese?
Plus 2.
Two.
+2. Can you write a reaction, half reaction for iron only? Half reaction.
5 Fe plus 2
Yes.
Why,
equal
the 5 is not important. I'm not going to run the 5. This time I'm not balancing. I'm just talking. So it is Fe 2 plus goes to what?
Equals Fe
Fe.
plus 3 plus E.
That's half reaction. Good. Is this complete?
No.
Plus electron
Where should I put the electron?
Right.
in the product.
Right.
Exactly. Is this oxidation or reduction reaction?
Oxidation.
Oxidation.
Oxidation. So the iron is what?
Oxidized.
It's oxidation, so the Fe2 plus
Reducing agent.
is reducing agent. Good. Now, what's the other reaction? MnO4 minus goes to what?
The manganese.
Mn2 plus. That's the other reaction. What happened here? Is this oxidation or reduction?
Reduction.
Where should we put the electrons?
Reduction.
And the reactants.
And the reactants. How many electrons should I put?
5.
5.
5 electrons. Why 5?
Because it
Because
was
it's
7.
close
To balance the electron.
7 to 5. Good. So it's now balanced. Okay, so is this reaction oxidation or reduction?
Reduction.
Reduction.
Reduction reaction. And MnO4 minus is what?
Oxidation reagent.
Oxidizing agent. Is this clear? So which one is the oxidizing agent of this reaction?
B.
MnO4.
Can we say C? I mean D.
No.
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 When you say oxidizing agent or reducing agent, you talk about only reactant. So it's either this one or this one or this one. It cannot be these two. These two can never be reducing agent or oxidizing agent. And of course, the reducing agent is the one that will lose electron, and the oxidizing agent is the one that will gain electron. So yes, the answer is B. Don't forget this. I hope so. Good. Next, if we have H2SO4, what's the oxidation in sulfur?
Plus 6.
About others? Everybody, do you have any other idea?
Plus 6.
Yes, it will be plus 6 because H plus 2.
Exactly. It is plus 6. So yes. Okay, next, number 9. What volume of 0.452 molar NaOH solution is needed to neutralize 85.0 milliliter of 0.176 molar solution of H2SO4? So what did we do here? We reacted NaOH with H2SO4 to make what?
Na2SO4.
H2O.
Na2
SO4
SO4
and H2O.
H2O. Good. Is the equation balanced?
No.
What should I do?
2 with NaOH.
It's balanced now. Good. Read the question and solve it.
E.
Huh? How can I solve this?
M1 V1 equal M2 V2.
Well, you have to be careful. I think the best way to solve this one is to put the information under each one of them. So this one is 0.452 molar, right? And this one is 0.176 molar. What's the volume of H2SO4?
85 milliliter.
Milliliter. Good. And I want to know what's the volume that's needed here. Okay. I know from the equation there's 1 and 2 here. What does that mean?
The ratio from NaOH to H2SO4 is 2 to 1.
So the first
For
thing,
moles.
always deal with moles to be safe. Can you calculate how many moles of H2SO4 do we have?
Yes.
It's 14 and 96.
96? Oh, don't forget to multiply this by 10 to the minus 3.
Oh, wait.
Quickly.
It will be 0.014, 0.015.
Now give me more numbers. And don't start with 0. Start with 1 point
1.4
more. 1.4 what?
multiplied by
96 after 4.
96. Multiplied by 10 to the power
Minus 2.
2 mole. Good. How many moles of NaOH do I need?
Twice of it.
Very important.
multiplied by 2.
Multiply by 2, exactly. And if I multiply by 2, this will be 9, and then 9.2 times 10 to the power minus 2 more. Do it in the calculator and get the same answer. Then I make the right answer.
The answer is B.
What?
The answer is B.
Just say. Now, find the volume. How can you find the volume? Divide the number of moles by the molarity. Divide the number of moles by molarity. What's the answer that you have? Divide this number
6.6 times 10 to the power minus 2.
6.62 times 10 to the power minus 2 liter. And then can you change it to milliliter?
Times 1000.
Which is going to be 66.2. So what is the answer?
B.
B.
Doctor, we don't need to convert milliliter to liter in the first equation, right?
You don't have to, but you have to be careful. No, I mean, if you don't, then there will be a problem. I prefer to change it, especially we already calculate the moles here. So if I want to change it to mole, I must multiply by 10 to the minus 3. Otherwise, if I don't multiply by minus 3, I should use the word millimole.
Yes, and you will get the same answer.
Yeah, of course, it will be millimole. If I put the unit millimole, then I don't have to multiply by 10 to the minus 3. Okay. Good.
Okay.
Last question in the homework. I have a solution which has concentration of 1.35 molar. And they want to prepare 5 new solutions. 1, 2, 3, 4, and 5. How am I going to prepare it? By sequentially diluting 5 milliliter of each solution to 100. How can I dilute 5 to 100? Take 5 from here, 5 milliliter, and put it in 1, and add how much to it of water?
100 milliliter.
No, we add
95.
what?
Add 95.
95 plus 5 is 100. And I added 95 water. I want you to apply the rule M1 V1 or MC VC equal to MD VD, volume diluted. So what will be the concentration of 1? What's the molarity of 1?
Doctor, can you please open
6.7.
the attendance because I have an English test.
Yes.
Can you please open the Microsoft, check the attendance because I have an English test.
Okay, good. It is open now.
Okay, thank you.
Okay. Yeah, you can take attendance and leave. Whoever wants to leave. Okay, now I took 5 from this one and put it in this one, and I know the concentration here, and I know the amount 5 milliliter, and I made it 100 milliliters. So what will be the concentration?
6.75 times 10 to the power minus 4.
I hope somebody got the same answer. Okay, next, I took 5 milliliter and put it here. I took 5 milliliter of this one and make 100 milliliter here. What will be M2?
3.38
3.38
times 10 to the power minus 3.
I wish more than one read the, do the calculation so that we're sure. I'm just copying what my friend says. Okay.
Yes, that's correct.
Then I'll do the same thing. I'll take 5 milliliter from here and make 100 here. What will be M3? This means multiply this by 5 and divide by 100. That's all.
$1.69 times 10 to the power minus 4.
4. Let's do it from here to here. What's M4?
8.44 times 10 to the power minus 6.
And then let's do 5.
4.22.
So M5 is equal to what?
4.22
4.22 times 10 to the power
minus 7.
Minus
7. And this is the correct answer. All right. Yes, with this, I'm done with today's lecture. And don't forget to do his homework for chapter 4 and submit the attendance now. And I'm going to leave even myself. Okay, go ahead and start submitting.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you.
الله يحييكم.
دكتور
دكتور
Yes.
اقدر اشوف اجابتي حقت الكويز في البلاك بورد؟
تقدر رسموه الان الحقيقه اليوم الحين انا ماكو موجود يوم الاثنين ان شاء الله بعد المحاضره اجلس معاك في الاوفيس اور واوريك.
تمام يعطيك العافيه دكتور.
دكتور الحين المركبات اللي حالتها غاز ولا ليكويد نقسمها بالايونيك كومباوند زي الاكويس ولا لا؟
السؤال
بالايونيك فورمولا المواد اللي المركبات اللي حالتها ليكويد ولا غاز اقسمها زي الاكويس ولا لا؟